Okay, so here is also the sheet for the officer application. I can also post it in the chat. I'm also gonna post in the chat of the video for whoever's watching this video. Watching the recording, I mean. Okay. Shoot, I forgot to share my screen. Okay. Yeah, so this is the information for the application. If you want to become an officer, please note that one important thing to know is that it's UW Seattle students only because of rules, the red tape. Andy, are you done? Sorry, I'm not sure if you're done or not.
Sorry, I'm just having my dinner right now.
Oh, okay, no, that's fine. If you're not done, that's okay. Just like either like submit the form or just tell me in chat. Is there anything you'd like me to go over today? Do you need help with anything?
Not really. I haven't go into the too much detail right now.
Okay. Um. Hmm. Let's just have you. You can work. I'm not really sure what to do for today then. Like, how about this? If you want to work on it right now, and if you need if you have any questions, like you can ask me. It's up to you, or you can leave this.
Oh, okay. Since
So
I'm just having my dinner right now, so probably
dinner.
like.
Okay.
Mhm.
Um.
Okay, I see that.
So. Hmm. Um. I'm not really sure what to do right now. Okay. this is what I'm gonna do. I'm just gonna go over the office positions, and then let's try creating a template algorithm. I'm gonna try creating a template algorithm for the QL project. That's what I'm gonna do. Okay. So this here, I'm just gonna open on my computer. Open as PDF. Okay, so right now the officer positions for the Algorithm Trading Club is open. So you should email it to me at this link. Include like any important information like your resume, relevant links, etc. And please also include times that you're available so that I can schedule a call or something like that. Okay, so there's a head quant. You're gonna help teach as well as like develop like code using like papers or like articles or something like that. Like it can be from papers or articles or anywhere else you find something interesting. You can help teach some workshops. We might have workshops like alongside the projects, and so it's hard to do both, right? Because it's like, but we sort of need both because you need the workshops to cover the basic skills, and then you need the projects to like apply the skills you learn in the workshops. So the head quant will help with that. You want to be a public relations officer. You reach out to companies and try to form a relationship with them. You also develop promotional materials and build out the ATC website. Okay, let's go into Quant Connect. Okay. So let's first create a rolling window. Self.rw equals rolling window. And this will store the slice data. Let's do like 200 days. I can't, the paper will have more specific information, so you might like need to change some of these numbers. Then what we're gonna do is, let's just create some ticker, no, okay, so tickers equals, let's create a list of some tickers, maybe JPM. Wells Fargo, Goldman Sachs, and Bank of America. Back. Okay. Then so for ticker in tickers, self.add equity. Ticker. Let's do daily resolution because that's what happened. That's what's in the paper. So resolution.daily. And then let's do it's currently what's called symbols. Let's do this. So the self.add equity returns like the symbol wrapper class. I mean, no, it returns a security wrapper class. Here, let's look at it. And so inside the security class, there's the symbol field. And the symbol is, if you remember, one of the previous workshops, I talked about how the symbol was sort of like a wrapper for a ticker. And if you actually wanted the underlying ticker, you just do .value. But as explained, I think it was last week's meeting. The reason we use a symbol wrapper is because like a ticker for a stock might change over time, right? And so like something like say it was APPL, it could go to like APLE or something like that, right? Or APLL. It could change over time. And so instead of using like the raw tickers like JPM, WFC and stuff like that, we add it and then we access the symbol. And the symbol, so the symbol is more dynamic. It automatically tracks the changes through the backend. Okay. And so we added all these symbols. Let's actually do self-dot symbols. So let's for symbol no if not all symbol. So data dot bars to access the OLHLCV bar thingies, because like a slice. So this data is a slice object, as I explained last week. This is a slice object, okay? And so let's look at the slice class. But this slice contains more than just bar information, like candlestick. So these are basically candlesticks, okay? But it has like other information like dividends, delistings, okay? So we did dot bars to make sure to access the candlesticks. It contains key. Self dot symbol or symbol in self dot symbols. Okay. So if we don't contain data for all of them, then we just return. And then what we can do, but if we do contain data for all of these symbols, we can do self.reload.add the data. We have the slice. So this is the only one that can store slice objects. You can also store like stuff like floats. You can store Boolean. But we want to have slices. So we put slice. It looks kind of weird. It's like, why are we indexing slice and then passing it to 200? I think this has something to do with the C# backend, because this is like a C# like object, okay? And then what we can do is if, then we can have a scheduled event. So let's like tune our parameters every month. So self.schedule on self.time date rules dot month start symbols 0. So that basically takes the first symbol in our list, probably going to be the symbol for JPM, and the month start of the security. So the month start of JPM. But the time rules dot after market open. So that symbol is 0, and then so what's the point of this self dot after market open? Why do I have to pass in a specific symbol in there? Well, that is because securities for different asset classes or even different exchanges open at different times. So like if you think about the crypto market, it has, I think it's like near 24/7. Meanwhile the hours for stocks is 9:30 to 4:30. So you can have vastly different times for different securities. Okay. And then self-dot return. So we're gonna have a function that will return our data. So def return. And actually, let's create a self.model every month, and I'll explain that later. So self.rechain, self, and then so if self, so we want to check if our rolling window is full. So if self.rolling window dot is ready, and is ready is basically a field that tells us whether or not the rolling window has the specified number of specified number of elements. So it has to have 200 elements before it's ready, and full. It's full at 200, and ready at 200. Okay. If not self.rolling window is ready, we will have to return early. Okay. And then what we can do is create the data. So we can create a data frame equals df equals self.pandas. Actually, I forgot what it was. So what I'm going to do is go to GitHub and copy it. Truth is, the thing is, like, not everyone knows everything, okay? There's no shame in just copying. I found it right here. You can always Google it. Oops. I don't know if you can Google it. Quant Connect. Yeah, this isn't really well documented. Sort of, and as explained last week, rolling windows is sort of like backwards in order. So we do iloc, integer locate, integer indexing, blank blank. So start to end. So it's like this. It's sort of like most of that. Well, this won't actually work because df isn't defined, but it's hopefully you sort of get what it's trying to say though. So we get everything from the first element to the last element. So just blank. And then what we do is the increment, we go -1. So what happens is that, so we can, if we put 2 here, we get every other element. We get every third element. But if we do -1, we get all the elements backwards, okay? So that basically fixes the ordering. And then let's train our model. Okay, so self.model.train, yeah. Well, if you notice here that the model's none. So let's create a new file. Let's see how to do that. Model. So class model def init self. We have something, blah, blah, blah. Def train self df. Self.parameters equals something. And then you can do like self.parameters equals blah, 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 something like that. Probably want to import some libraries like import np import stats. Okay, so then you do something and then you create some parameters. Okay, that makes sense. Okay, so so if models. So what we can do is now we can import that model class. So from model as in the file, import model as in the class. Let's just do model class. Just so like the distinct name is clear, okay? So model equals model class. And then set the model to train. And that's basically, it's pretty basic template. Okay, hopefully that all makes sense. I'm gonna post this in the chat as well as the video. Okay, so I think the hardest part of this project is probably doing the quant connect stuff because, well, it's not actually. It's probably not the hardest. I think the how do I put it? Challenging. One challenging aspect might be getting used to the quant connect KPI, but so to address that, I made this template, and hopefully it should go a lot smoother. So yeah. So we got a little time left. Andy, do you have any questions about what I just did?
Not really. Thank you though.
Does it all make sense? Is there any lines that don't make sense to you?
Actually, I'm kind of lost because I'm not really familiar with those object-oriented programming.
Okay.
Yeah, I will spend some time to figure it out.
How familiar with Python?
Yeah, I do familiar with the Python, but like I don't have any like experience with the object-oriented programming.
I mean, we're not doing anything complicated with the objects. Like, so here, maybe I can just go over, like, we still have time. Let's go over what objects are in Python. So to create an object in Python, you do class. Let's just call this person. And we do that. So to create a constructor is not necessary, but this is what the constructor is called when an object is created. Okay, so that's the definition of constructor. Okay, and let's maybe ask for something. So like age, name, age, and height. Self name equals name, age equals age, height. And so the reason we have to store these information is because of scoping issues. So these three parameters are like, say we have a def, say name, self. Oh, and also self is basically this in other languages. Okay, so print self dot. So the reason we have this self dot name equals name is because we have it here, but these three fields are localized to this function, whatever is here. So on this indent level, under this function init has access to name, age, and height. And so when we go to this say name function down here, it is not part of the scope of here. We do not have access to these three arguments because it's called to this here. So it's not here though. So, but what we can do is save it to the object, the self thing. Self.name, self. Okay. So that's why we have to store these things using self blah 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 equals blah blah. So let's create a person. Let's actually do print height. So a Bob equals person. Okay, so we can see that when we created this function, this init function was called. Actually, let's just. So everything inside here is being called because this function is called when an object is created, and we created an object here. So you can basically think of this class person as a template. It's a abstract thing that sort of represents something, like a person. Like if you point at a person, they are a person. But if you point at another person, that's a different person. But they're both people, right? So a person is like this overarching theme that describes a variety of, well, it describes people. But to become more specific, like who is that person? Like Bob is a person. Well, maybe let's give him a last name so he's more specific. So there might be okay. Actually, let's make this me. So I am a person, right? And so an object is a specific instance of a class. So if we, in our example here, Schiller when is a specific instance of a person, okay? And so what happens is this person, so this Bob is now object. And this Bob here is the same thing as this self here, okay? So when we do call bob.sayname, and we call this function on Bob, what we're basically doing is this, okay? So that's what the first argument itself. It's basically this thing here. And if we had a Steve, well, let's know why Steve. Okay, let's do this bar. Let's just keep this. Let's name this Twin. This is me. When. So this is basically what it's doing. Okay. But Python automatically passes in the object for you. So you don't have to actually explicitly put that there because it automatically does it for you. And so even though there's one argument here, that the first argument is always reserved for the object that you're calling on itself. So it passes in itself to that function. But we can still, so if we had two arguments, number, we'd pass in one argument here. Oh, I need a, then I'll put it. And so this is what happens. Okay, does it make sense? So that basically object is quite simple in Python. And what happens if we want to like extend this person class? Let's create a class student. What we can do is to extend something, we basically inherit something. We inherit everything, we inherit. But let's say we want something else, def init. We want the same thing as up there, self, name, age, height. But now we want student ID, okay? So self.id equals ID. Then we have to do self.super name, age, height, dot init. So dot super, actually, I can't remember how to do it. I don't really extend stuff in Python. Okay, let's take 1 second. Oh, yeah, what I had was correct actually. The reason I forgot this is because you don't really like, even though Python supports object-oriented programming, You don't really do a lot of object-oriented programming in Python. Okay, so now let's create a student. Let's actually just copy those arguments. And this is my student ID. That's not my real student ID. Okay. Okay, there we go. So we can access the same thing. So that's say name, even though it's be calling on a student object now, because we inherited everything. Oops, we inherited everything. Oh yeah, there's this. Put that argument in there. Let's just delete this. And then ran it. Oh yeah, yep, this one too. It's kind of weird working with Jupyter because when you run a cell, only that cell is executed. So if you change the class and you still have an object that's like equal to the an object instantiated from the old class version, then then it still stays the old object. Well, you'll sort of get what I say. If you'll understand what I say if you use collab or Jupyter. Okay, but then we also have access to a new thing, student ID. I just call it ID. And then what we can also do, this is called overriding. So we can do say name, and we have to have the same thing. So what we can actually do is let's just copy it directly, okay? And then print self.name, and then let's do print self.id. Self.id. And so you can see that we overridden the old say name, which just says the name. Now it says the name and the student. Okay. Andy, do you have any questions on that or anything? I might end the meeting soon.
I see that. Thank you.
Does it all make sense?
Yeah.
Okay. Yeah. Hopefully object-oriented programming isn't too intimidating. It's just like think of like objects as like objects in real life, like fruit, apples, bananas. They just contain a collection of actions and variables. And then think of it more like abstract, like classes as more abstract, like, and then objects is like a specific instance of the abstract thing. Like, okay. So student is like an abstract thing. Like you see a person, you have multiple people that are students, but you can't have multiple people that like are Schiller Wenz or Guy Fieri. Can't have multiple people like them because they're like unique individuals. Okay, so I'm just gonna end the meeting for now. Thanks for coming, Andy.